and let's get started. Hi, everyone, and welcome to another one of our thematic webinars for the Efficiency for Access Design Challenge. Today, we'll be hearing about innovative thinking from one of our industry partners, Silard Liptak, an innovator in his own right. Before we begin, I just want to go over our usual housekeeping. I'm recording this webinar and its transcript, which will be available online. If you do not wish to be recorded, please turn off your video and/or mute yourself. And we'll share the recording and slides with you following the event on the CrowdSolve event forum page. So when you're not asking a question, please mute yourself to avoid any distractions. Here is the agenda today. If you haven't already seen in the waiting room, we have a Mentimeter poll going around that I hope you can all fill out. So if you haven't done it already, I'll be sharing the link on the next slide. If you're watching the recording immediately after the event, please feel free to fill them out as you go along, and I can include them with the post-event materials, all of our answers together. So as you know, we've changed our webinar format. Rather than straight presentations, we'll be hearing a short introductory presentation from our speaker, followed by the bulk of the session dedicated to a panel discussion and Q&A. So if you follow through our Mentimeter, you can submit questions to the Q&A at any time. Alternatively, you can raise your hand or put your questions in the chat at any time as well. Yeah, so I encourage you not to wait for the dedicated Q&A period. As soon as one comes to you, just feel free to share it. I'll try to integrate them throughout the session. Okay, so this is our Mentimeter. You can follow and go on menti.com, fill in this code, or follow the QR code. I'll leave this on screen for just a moment. So it will just ask you for a couple one-word answers, and this is just useful for us to understand where we're all coming from and begin reflecting on the subject at hand. So let me just leave this up for another second. Menti.com, and then it's just this code. I'll also put the link to voting in the chat. And we'll go over the responses in just a moment. Okay. While you're going through that, please let me introduce you to our speaker. So Silard Liptak, as you'll have seen from the invite, Silard is the CTO of Agsol, a solar agro-processing startup. Before Agsol, he worked in 8 countries on 4 continents, including Georgia Tech's Center for Distributed Energy, where he worked on the tech-to-market transfer of ultra-low-cost technologies designed specifically for the developing world. Silard leads Agsol's technology platform and is based in Nairobi, Kenya with his family. So I'm sure you'll learn a bit more about Silard during his presentation, but that's to come. Hopefully you've all had a little bit of time to fill in the Mentimeter. If not, we'll also be sharing this in the post event. But let's see, the question was, what word comes to mind when you think of innovation? And we have improve, a unique idea, and transformation. I think basic idea coming through, people understanding what they believe innovation to be. And I guess we'll see if Silard kind of contradicts that or where we go from here. Oops. There we go, betterment coming up as well. Coming to the side, little cloud. Creativity coming out as well. Okay. Silard, do you have your presentation? Do you want to go through that on your screen? I can stop sharing and hand over to you.
Sure, let me try. All right, and share sound.
Yes.
Optimize for video clip. Yeah, let's try that. Here we go. All right, can you guys see my screen all right?
Yep, can see it great.
All right, sweet. So yeah, good morning, good afternoon, good evening, everybody, depending on where you are. Thank you, Sean, for inviting me. As he said, my name is Silard Liptak. I'm the CTO of Agsol, the solar agro-processing startup. I'm hoping that during this presentation, the gods of the internet will be, very cooperative, and I hope that the internet connection is gonna hold up despite, our Kenyan challenges. Yeah, if Sean, if there are, if I'm coming across spotty or anything, let me know, and I'm happy to repeat anything. So today I'm going to talk about innovative thinking. From my perspective, I'm going to share with you a little bit about ourselves. What is Agsol? What do we do? Then I'm going to go a little bit into, what my thinking is about how innovation applies specifically to product design, product development, and product startups, tech startups more broadly. And then eventually going to share a bit of a personal story of how we went about the first version of the micromill, aka what not to do. So hopefully you guys will learn from our mistakes and won't repeat the same ones. So as a bit of a kickoff, there we go. As a kickoff, I just want to start with, a bit of a sobering truth. There are no silver bullets. There are no simple solutions. There are no geniuses sitting in an ivory tower ideating about the future of mankind and coming up with grand ideas that changes everything. I strongly believe all innovation happens in the midst of things. As Thomas Edison said, genius is 1% inspiration and 99% perspiration. And I very strongly agree with this notion. You have to have a spark of an idea, but that spark won't be coming, just in and of itself. It does need a very fertile breeding ground where it can be conceived and where it can grow into something, useful for hopefully the wider society, such as a business. So a little bit about us. I think this audience doesn't need introduction that 1 billion people have no access to electricity, and the overwhelming majority of these people are farmers. They are living in rural areas, poorly developed grids, poorly developed water utilities, poorly developed infrastructure, broadly speaking. And these farmers depend on agriculture for their livelihood. And they are extremely underserved, not just by public utilities, but also by private services, including agro-processing. So without further ado, let's just see what is the state of the art today. So what you are seeing here is a diesel mill. So it is what you see on the left side is the mill itself. In the middle of the screen is a diesel engine. It's an Indian-made diesel engine. I believe the nameplate said it was made in 1987. So this engine is older than I am. And still running somewhat miraculously. And what you see on the right side is a cyclone. It's something to separate the two. So let's just see how people are processing their food today. So let me just play this video. Hopefully it will be visible on your side. So these machines are hand crank. Hopefully you can hear the beautiful sound these machines make. They are incredibly overpowered, incredibly loud. That's where the loud just inside the mill freezer requires a lot of expertise. But quite smelly in there. The flour that comes out does smell magic that even I'm not sure about what it exactly means. The engine has a big cooling barrel that's not visible on the video, so that water can run through it and cool it. And as all diesel engines, as you guys probably seen in cars, require oil changes, requires oil filter changes. The spare parts are incredibly difficult to come across in rural Africa, and they break down very often. So yeah, why are people using such an extremely outdated and unsuitable technology? because there is no better alternative. You know, if you don't have a grid, if you don't have an electric motor to turn it, well, this is the solution, and it's been the solution for 100 years. And as you guys, I'm sorry, Sean, just checking, the audience are engineering students or other students as well?
We have a few others, but the far majority are engineering students.
Okay. So as the engineers in the audience, you know, are aware of, it's a really outdated technology, incredibly inefficient, incredibly expensive to operate, especially in rural areas where the cost of diesel is very high. So let's see what we can do. Maybe we can do something that's better. So this mill, as you will see on the next slide, is something that you can hold in your hands, quite opposite the other one. It is specifically designed to run on solar power. Okay, so we made the mill very, very high efficiency. And thanks to that efficiency, you know, the mill itself is more expensive, but the cost of the entire system is much lower because you can reduce the size of the solar system tremendously. So we are able to power it purely from solar. It is incredibly easy to operate. There is a single button on it that you need to push to turn it on. No hand crank, no physical strength required. It's not considered a man's job to operate this mill. And once it finishes milling, it turns off automatically. It is cheaper than a diesel or an AC equivalent mill. Needless to say, it does not consume fuel. So once it's installed, it is incredibly price competitive. It is 2.5 times more efficient than any other electric mills. And what enables all these benefits is a new novel technology, novel meaning half a century old only, called brushless DC motors or BLDC motors. These are very smart motors that are incredibly high efficiency, incredibly high power density, have no moving parts other than the bearings. And the downside is that they require more smarts, specifically on electronic controls that's spinning this motor. But in exchange for that, you know, we get a machine that's very, very user-friendly and takes care of itself, you know, has a lot of protections that conventional mills don't do. And it even has something that no other mill out there has, completely self-feeding. So the user doesn't need to stand there and regulate the flow of material. It can just simply dump the material, turn it on, and walk away, not having to do anything else. So let's see it in action instead of me talking. So I'm just gonna play this video. There we go. So this is the automatic feeding mechanism in action. The flour quality, what we call unga in Kenya, so human consumable flour. It's very easy to open up, very easy to clean, something that conventional machines are not particularly good at. You can change over to a variety of other finers like chicken feed. It's available both in solid format, AC format, battery powered format, wide variety. So that's our product. I think I can very proudly say that all other solar machines out there, I can proudly say that all other solar machines out there typically cost more than the incumbent that they are replacing. In our case, the incumbent is so outdated and so ripe for disruption that we actually can do something that nobody else can. We are cheaper on capex, on upfront costs than the incumbent technology. And then once you own it, of course, there is no fuel cost. So then it becomes significantly more cheap because diesel mills typically spend 45% of their revenue on diesel. So it's a not very profitable business. All right, so that's our product. On a very high level. If there are further questions, I'm very happy to go into more details. If you guys are interested, please check out our website agsol.com, and you can read more about the product and about our team. But jumping into more broadly the innovation. Actually, before I go there, does anybody have any questions right now from the top of your heads before I move on? All right, I take that as a no. So just confirming, can you see the top of the screen as well? Is the Zoom panel kind of blocking it out? Or?
We're losing a little bit of that first line. Otherwise, we can see it fine.
A little bit of the first one. All right. High floating meeting controls. There we go. Is it better?
Actually, another window has appeared in front of it. There we go. Now it's better.
There we go. All right. So jumping into innovation. So to be completely honest, I was a bit confused when Sean asked me. I didn't quite feel like like a creative person. I felt like that. Well, I'm finding creative solutions, but I did not quite identify as one. And one quote that popped in my mind that I think describes the situation very well is creativity is just connecting things, from Steve Jobs. Then he went on saying that when you ask creative people how they did something, they feel a little guilty because they didn't really do it. They just saw something. It seemed obvious to them after a while. So that's pretty much my philosophy as well when it comes to creativity. You have to be on top of your game. You have to know a variety of things, but once you know those things, it's only a matter of connecting things. So specifically, the two areas that I want to highlight are engineering first principles and knowing your customer. So what I mean by engineering first principles? If you've been unlucky just like me, who received a not so excellent engineering education, you may have received a very superficial view of things. Hey, a transformer is a black box that transforms one kind of electricity to another. All these power electronic appliances are just magic that randomly make things work. I don't know, brushless DC motors are just another kind of electric motor. It's a bit better than the old ones, but hey, I mean, yeah, it's not much of a difference. And that's lethal. So I cannot really sugarcoat it much more. If you want to be able to do engineering innovation, you have to really know engineering. You really have to know the first principles that are driving these designs. You really have to know the difference between these. And if you've been unlucky just like me, then what I can recommend is that, hey, you are the master of your own destiny. Grab online courses, really brush up on the fundamentals, and all the rest just naturally falls out. So as for myself, I did take online courses from MIT, and I pushed to complete my master's in a better environment. I was privileged enough to receive a scholarship to the US, where I feel like my engineering skills were improved tremendously. And I cannot emphasize the importance of this enough. Do not reason by analogy. Analogy is like, well, it's something like this other thing, and that never works. You have to understand the first principles. Why and how is it different? You have to challenge assumptions. Everybody knows that lithium-ion batteries are more expensive than lead-acid batteries, except when they are not. These kind of high-level superficial assumptions are really holding back design, and I'm going to come back in our in our own experience, how these assumptions were holding back product development in this area. Another one is knowing physical limitations. You know, one side is know what is possible, but the other side is know what is impossible. I think I don't need to tell the stories of recent startups, but that have been overly ambitious in their goals and have just not respected the laws of nature that cannot be broken. And you have to know how to navigate this world. As an engineer, your job in an organization to interface between the human world, what people want, and the physical world, what is possible. And you are the expert to translate those needs to designs, to implementations. And what you want to do is be a lazy engineer. You always want to find the easiest solution that works, gets the job done, simplest and cheapest. So yeah, feel free to drive for laziness. And speaking of interfacing with humans, the second key thing that I would like to emphasize is knowing your customer. I cannot emphasize the importance of that. You know, hit up any modern books about startups or product development, and this is where it all begins. We as engineers tend to be a bit more, how to say it, a bit more shy, maybe a bit more, you know, restrained from just going out and talking to customers. But I'm afraid there is no easy way out of this, and there is only way to really know your customer is to meet them and to talk to them. Like I said at the beginning, it is impossible to innovate in a vacuum. Believe me, I tried. It's a really bad idea. You have to know the tiniest details of a customer's needs. And when you don't, and you make assumptions, those assumptions basically always turn out to be wrong. One of the advices that I've read in the book Lean Startup that I'm a strong proponent of is that whenever you make an assumption and whenever you put a number down in an Excel sheet that you assume to be right, make sure to mark it red, make it bold, make it stand out, put a ton of exclamation marks around it, because that one number can screw up your design and in a broader sense can undermine the fundamentals of your business. So always know what your assumptions are and always strive to validate them as soon as possible. And finally, one of my favorite quotes, this presentation is quite heavy in quotes, as you can see, is coming from Henry Ford. And he said, if I listen to my customers, if I had asked my customers, they would have said they want a faster horse. So, it is important to listen to them, but don't always do what they tell you. Okay, you as an engineer, again, is the interface between the human world and the natural world. You can translate the customer needs into a design that fulfills their needs. Okay, they don't need a faster horse, they need a car. And just like our customers, they don't need a cheaper diesel meal, they need a completely different kind of meal. So with that, I'm really hoping you guys have come across the lean design methodology or the lean startup book one way or the other. If you haven't, I strongly recommend to Google it, hit it up, buy the book, read it. It's really the state-of-the-art way of making new ideas come to life. But if you haven't, I'm just quickly going to give you a 2-minute crash course on one of the main ideas, and that is that where you start with an idea, you got to build a product, and for that idea you do need an in-depth knowledge of the customer and their goals and a very, very desperate need that they have that you are aiming to solve. So build a product, but again, don't spend too much time on it. Okay, what you want to shoot for in the first iteration is something quick, something easy. It doesn't have to be perfect. It has to show the main functionality We call it a minimum viable product, or MVP. Then once you have it, you need to measure how that product is performing. If there are any features that's taking time to develop or to maintain or cost a single cent that is not contributing to the success of the product, you need to cut it out. If there is any feature that the customer needs and can be improved on, even if it's expensive but worth the cost, you need to make better. And the only way you can tell the difference between the two is by measuring. And here comes the most important part. You need to learn, and you need to go back and iterate. Iterate, iterate, iterate. And you have to do it fast. You have to minimize the time through the loop. And you have to quickly complete this build, measure, learn loop as quickly as possible. Because your first step at it, let's be honest, is not going to be great. And just reiterating my previous point that the first assumptions are never right, that is seen everywhere. Okay, that's not just in the off-grid solar sector, that, as software, as hardware, everywhere. Airbnb is called Airbnb because it stood for Air, Bed and Breakfast. It was originally made so that you put up an airbed in your room and people can just come, crash at your place and pay you something. Today, people are building houses specifically to be put on Airbnb. Facebook started out as something where you can, keep touch with your college buddies. It grew to be something much more different. And same with our product. Our first assumptions were wrong, and we paid the price for it. And the only way to really resolve that is to know your customer, and to know your customer, know your tech, and iterate quickly. So some footnotes before I move on to our personal story. I'm gonna make it pretty blunt. Patents in our industry are dead. If you are hoping you can, come up with a good idea, patent it, and live from it for the rest of your life, that may work in nice closed systems like the US, or within China, or within the EU. But in an international environment like we are operating in, typically the developing world, they don't provide a lot of protection. You can patent your design, but you have to pick a geographic location. Like, do you patent it in Kenya? That doesn't give you protection in Uganda. You patent it in Kenya, Uganda, doesn't help with China. You patent it in China as well, doesn't help you with India. So you would have to have a very elaborate patent strategy, and a very expensive one to implement that, or just have to accept the reality that patents don't give protection. Even if you have a patent, that only gives you a ticket to sue someone, but it does not cover, it doesn't automatically yield results. It doesn't automatically guarantee that you come out winning. And it's a very routine tactic by incumbents to starve startups of cash by simply suing them. So unfortunately, patents are not going to be your friend in this industry. You have to out-innovate your competition. You just always have to maintain your edge and always be 6 months to a year ahead of them. That's the only way to stay in business. The other one I want to mention is innovation risk management. We engineers love innovation, we love creativity, and we love cool features, and so do I. But you have to know that every time you come up with a new innovation, you are introducing risk, and that risk has to be balanced. So always, whenever you brainstorm about a really cool new feature, always weigh it against reliability. How can it break? How does it affect your core product functionality? And you have to introduce these changes gradually, and you have to be very careful about how you're going about them. And the last one is just generally, hey guys, be informed. Know your customers, know your tech, that's for sure, but know your business and know your industry. There is no need to reinvent the wheel. business is a collaborative art. If somebody has already figured something out and willing to, provide that product or service, don't try to do it by yourself. Don't try to reinvent the wheel. Work with others, know what others have done, know how they succeeded or didn't with that, and know how you're different, so you're not making the same mistakes. So with that, I'm just looking at the time. I will have to speed up a bit. Let me tell the first story of how we developed our first micromill. So as you can see in the bottom left corner, it looked quite different from what you've seen on the video. It's much bigger, it's much more expensive, and much slower than our current version. And we made a number of mistakes that's big in the book during the development. So starting from the top left, we started saying we know what the customer wants. We don't need to go out and talk to them. There is this report from the World Bank. There is that report from WFP. There are all these reports out there that very smart people wrote. Surely they must be right. Second-hand information is as good as first, and why spend any time talking to pesky customers in dirty environments? That's no fun. Engineering is fun. So we said, hey, we know what the customer wants. We don't need to waste any time with talking with them. And hey, what they want is a mill that can replace a diesel mill. Check mark. So we went into the technical design straight away. A lot of technical skepticism came up, like what I mentioned, that hey, we need an affordable machine. We need to make the machine cheap. That's a bad idea. What you need to make sure is that the whole system is cheap. If the machine is cheap, but it takes a $2,000 battery to run, it's not going to be an affordable machine. Another one is that a bearing can't take a 12,000 RPM direct drive mill. That's too fast and they will break. Again, engineering fundamentals. Why? I mean, conventional mills out there do use bearings that can survive this. So why would that possibly be a problem? Why would direct drive be a problem other than a massive gain in efficiency? So when it comes to technical doubters, and I can guarantee you will come across them, don't be afraid. Go back to engineering fundamentals, see if it makes sense, and if the nature allows you to do something, then go ahead and do it. Don't spend time with your doubters. And another early skepticism was we cannot use lithium-ion batteries, they are too expensive. Well, I mean, true on a per watt hour basis, but again, if you go back to engineering fundamentals, their C rating is much higher. So you can run a machine on a much smaller lithium-ion battery than you would need a lead acid battery for. So basically, you can, instead of spending $2,000 on a battery bank, you can spend $200 on a battery bank that can both power your machine and use a more expensive technology. So again, superficial knowledge is a killer. Always know the first principles. So we started doing, specification creation in a vacuum. I was sitting in China at the time, coming up with ideas what Kenyan farmers need, because I surely know what those guys need. I've lived in Malawi, I've lived next to a posho mill. It's fine. And we came up with the idea that, hey, I mean, how many hours would these guys run a mill? 8? 8 sounds like a good number. 8 hours, yeah. So let's say they are running it 8 hours a day. And when are they milling? I mean, they're not milling at night. It would be dark. So they're milling when the sun is shining. I mean, that's what a mill is good for, right? I mean, a solar mill makes perfect sense. So these two assumptions should have been marked with red and surrounded by a ton of exclamation marks because they were dead wrong. All right, let's just fast forward 1 year until we figured that out. So we went ahead, engineering fun. We developed the first proof of concept. We developed something that was much more efficient than the others. We brought down the system cost. It was direct drive. It was so cool. It was really amazing. We built the first prototype. Just to give some context, the top picture was taken in July 2019. Then we spent roughly 6 months, putting the first one together. So I demoed the first prototype in Kenya in February 2020. That's when COVID really hit, and that caused us a lot of difficulties. We lost access to China and our factory and our staff there. But on the silver lining, the prototype seemed to have received really good verbal feedback. We were in full sales mode. We don't need to listen to the customers. We know what they want. And here it is exactly, people seem to like it. So we built 10 MVPs, minimal viable products, and we deployed them over the course of 2020, thanks to COVID in a very slow pace. And what we found once we really started talking to the customers towards December of 2020 is that it was not a failure. It was not a good product market fit. It was a good product, but not what people needed. We completely disregarded the culture. The culture is that we don't want to run the mill when the sun is shining. I don't want to drop the maize down and come back for it later. I want to mill now when I'm at the mill. I walk for an hour and I want to see my maize going into the machine, not the neighbor's maize, not a good friend's maize, not that obnoxious guy from the market. I want my own maize because I spent a year growing it and I'm very personally attached to it. And when people are coming, they are coming at the same time because diesel mills don't get turned on unless there is a long line of people. And here the speed was just not sufficient. And the utilization, we almost also completely got it wrong. We said, well, they probably would run it 8 hours a day because that's what I would do. But what we did not consider is that even diesel mills are barely run for an hour a day. And most mills are facing very low utilization, and these rural areas tend to be extremely sparse and low population density. So the utilizations are much, much slower, and the unit economics with that collapsed and crumbled. So there we go. We went back to the drawing table and came up with the second version of the mill, what we saw on the video and what we are selling today. That really unfortunately had to tackle these issues at the fundamental level and resize the motor, had to increase the production rate, the power rating, and yeah, I'm not going to go into more details, but had to make a lot of changes to create a much better product market fit. And again, we could have done all that right at the beginning. And you feel like you don't have time, you don't have money to spend a month running around rural Africa and talking to customers. But look at all this waste that you could avoid down the road, which is, I'm guaranteeing you, costing you a whole lot more time and a whole lot more money. So with that, thank you so much for your attention. I want to say we are open to internships. My email is silard@agsol.com. If you're interested, please feel free to reach out. And yeah, I'm happy to jump into the Q&A session.
Thanks, Silard. That was that covered everything, really. So I hope our students have any questions. So if you have any questions, feel free to put them in the chat, follow through the Mentimeter, raise your hand, whatever you like. In the meantime, I have my own questions, although Silard, I think, answered a lot of them, which is great, which is really great. Yes, please just send those in whenever. You don't have to wait till the very end or when I'm finished asking questions. I'm sure you all have them, especially as it pertains directly to all your assessment criteria. And Silard had a lot of great lessons there from his own experience. Okay, so just touching on something you said quite early on. You mentioned, I mean, there's a big focus on understanding your end user. but I would think that most people would be considering their end user throughout the design process. And I was wondering what kind of recommendations you have for someone trying to get an edge on the competition. How do you innovate above the competition in trying to understand your end user? How do you understand them more deeply?
Yeah, thank you for that question. You sent it over to me previously, and I love the optimism in that surely engineers must design with the end consumer in mind. And I'm just really terrified to see that is very often not the case. A lot of time, I mentioned to you before, and this is a saying of a former supervisor of mine, is that we train engineers to answer questions. And we engineers are really good at solving problems and really good at answering questions. But where we are bad at is asking the right questions or finding the right problem. And I'm just seeing it time and again, especially with student teams, to be perfectly honest, is that they find a complex problem, don't validate it, don't check whether somebody is actually facing that problem. They just like, hey, that is something that would be cool to solve, and just jump straight to the engineering. Just like we have, like, look at the top part of that little curve. We're like, okay, problem, yeah, boring. We know what the problem is. The people need better off-grid milling. Yeah. So jump straight to brushless DC motors, direct drive, because that's so much fun. So, I think it's very important to, again, go back to the basics, both engineering wise and your customer wise, have direct access. A lot of our competitors, I'm just seeing the products that they come up with. And, we are based in Nairobi, Kenya, and, most of my colleagues are Kenyan. And I show them a video of the product and they just laugh. It's simply so detached from reality that it's obvious that they have not, it will take them some time to really put the product in the hands of the customer and get that feedback, that they are just not realizing how far away they are from a product market fit. And on the back of a product market fit, an organic growth, that's essential to all businesses.
Thanks, Silard. And on that, actually, I just wanted to ask our students, again, in the Mentimeter, if you can, I wanted to ask how all of you are approaching innovation. And maybe we can look at that in the end and see if what kind of answers we get. Because as Silard said, many students are not maybe more interested in addressing a problem and sorting out these cool design issues rather than really thinking about the end user. So I just wanted to hear a bit about how everyone else is approaching this. And then on this, you mentioned the kind of assumption you had about BLDC motors, and Khalid in the chat asked, in your micromill you use BLDC motors, but it needs more power. So why don't you use any DC motor? What was the kind of the edge of the BLDC?
Thank you for the question. Khalid, I gotta say, we gotta go back to engineering fundamentals. Why does it use more power? I'm sorry, you're on the call, right?
Yeah, Khalid is here. Khalid, would you like to answer that question? I don't know if you can come off mute.
Can you ask again? Sorry, I didn't hear it.
Sorry, my question was, why do you think that a BLDC motor needs more power than a DC motor?
I'm actually saying that the reason why I'm saying that a DC motor is actually consume less power than a BLDC motor. So why you actually used it? That was my question.
Yeah, so
I know
again,
BLDC motor is more efficient. Maybe it is more faster than the NEDC motor. It has the less power loss since we use the brushless. But why actually we don't use nowadays a DC motor for a milling purpose? There was
So exactly going back to engineering fundamentals, a brushless DC motor uses less power than a DC motor to drive the same, angular load because it's higher efficiency. So, these kinds of, assumptions are what's, are keeping back the industry. Brushless DC motors having a motor controller also gives you more complete control over the machine. DC motors, when you're starting them up without any control electronics, they are drawing a huge inrush current, and you don't really have to size for that. The brushes need periodic replacement, and that's not something that is very workable in rural Africa. They are creating large amounts of arcing, aging all electrical components. So, for a variety of reasons, and brushed motors are used by our competitors and are used in the industry. But if you start doing the math and seeing the number of hours these machines needs to run, you will quickly see that they are not a viable alternative. And also, for the record, they are less efficient. That means if you look at the machine on a input power, output power losses perspective, for the same output power, you have more losses, therefore you need to input more power. So they are consuming more power. Okay, I hope that kind of answers the question.
Yeah, I think I have a follow-up with that. So considering Khaled has made this assumption about BLDC motors and DC motor differences, how do you go through your design process and really identify and address all of your assumptions that you made? Because something like that wasn't necessarily about the end user. It was about something that he really considered was a flat engineering principle or design principle. So how do you work through all of those?
The format depends on what you're most comfortable with. It can be a whiteboarding session where you just kind of sit down with your friends and team members and kind of state your assumptions explicitly. It can be in an Excel sheet. It can be on a piece of paper, one way or the other. But do state your assumptions and make sure that like I said at the beginning, engineering first principles, that you do not rely on broad generalizations, but really based on the natural truths that are in action here. In this case, kind of neodymium magnet versus electric magnet kind of first principle. Whichever format you're most comfortable with, do state your assumptions and validate them.
Okay, then I would make sure everyone as well write those down and try to identify them whenever you can. So we have a couple more questions in the chat as well. One that's kind of big from Mika, asking, how can I be innovative?
That's, I guess, is the title of the presentation, right? Again, my answer to that is Steve Jobs' famous quote, creativity is just connecting things. So I think that you are innovative already. You just need to be exposed to the right dots that you can connect in a different way. So, know your technology. If you feel like your engineering fundamentals are not solid enough, make sure to improve them. That will take you, much further in life, just like I have, and I've been unhappy with my engineering training. Know your customer, know your industry. And once you have those dots laid out in front of you, you will see that you will have ideas that others don't. And you will inherently, by the stochastic nature of humans, you will approach the problem differently than others. And that is where true innovation comes from, if the building blocks that you are leaning on are solid.
Right, and I think Silard made a great point early on that we have a huge wealth of resources on the internet now. and you can tap into those at all times. I will be sharing some resources related to lean, what was it, lean design engineering.
Yeah, you call it the lean startup book, or more broadly speaking, the lean product development that grew out of it.
Sure. So I'll be looking up those books and putting all those resources on the follow-up post. So please look out for those and check those out.
Yeah. Also, this presentation, I'm happy to share in a PDF format, Sean, if you wanna share it with the guys.
That would be fantastic. Yeah.
Sure.
Peace asks a more logistical question about the micro mill. Are there occasions that the mill couldn't operate due to weather changes?
Absolutely. Thank you. Yes, like all solar systems, there are conditions where you just can't operate. If there is no sun for 3 days in the rainy season, you have to size for that. So this variable is called level of independence, and it is measured as time. And basically, this shows you, how long can your system run with a fully charged battery with no solar input whatsoever. So this was one of the key innovations that we made back in 2019, that people always assumed that rural African customers are, a German guy designing a product for rural Africans. They are going to assume the rural Africans are like Germans, and Germans sure love reliability and they want 100% dependability. That means that I need a system that can run for 3 days, even if the sun is not shining, because I cannot live with the fact that I may lose power. I strongly challenge that view. My experience has showed that people sure value, reliability, but they also, really like affordability. And having a $2,000 highly reliable system is not very user friendly. So what you need to do to be able to, I'm sorry, I'm just getting a lot of background noise, so just disabling that. So what you need to do to really is, again, know your customers, challenge assumptions, and accept the fact that, hey, these people living in rural areas are living in such an uncertain environment that they are willing to accept uncertainty if it is financially affordable. So we basically ran tests, and we are still running that test, that the mill is able to run without solar in its default minimal package for 40 minutes, or it can mill 40 kilograms. Okay, so it's not much. It may feel like that, oh, geez, that's, I have a cloudy afternoon, or I have, nighttime milling, and I'm out of juice. And that's true. But what we did is like, sure, guys, you can buy a second battery for $200. Do you know how many people took that offer up? We had 2 out of 100. So, you kind of have to look at the normal distribution of customers, and you have to kind of shoot for the middle. And if somebody wants more, sure, do it, offer it. You can buy a second one. We are compatible. It's fully possible. But always know what the mean market demand is, if that kind of makes sense.
Thanks, Silard. And I think you answered this last question. We have to let you go now, but I just wanted to ask this last question that Peace sent is about what the milling capacity is, a certain weight load. Was that 40 kilograms? Oh, but it actually asks daily. So
daily, that's right. So it can run 40 minutes without sunshine, the middle of the night. On the average day, it depends on how much solar you're putting on it. If you put, 600 watts, you can, even in rainy weather, annual average around 2 hours a day. So that gives you 120 kilograms a day. Sorry. So we went out and surveyed diesel mills, because again, the first assumption that, hey, the World Bank and WFP brought all these amazing reports. I mean, surely they know what they are talking about. Well, we went out and checked the data ourselves. Well, first of all, the data that we really needed was not available, and 2, what was implied turned out to be absolutely wrong. And when we went out and surveyed diesel mills, we found that the average daily capacity that they are milling, and these are again huge systems with several horsepowers of power rating, they typically mill 110 kgs a day. So that's what we sized for, and that's how. Again, if you want to mill more, not a problem. You need more batteries, you need more solar, easy peasy, Lego building blocks. But again, we are not sizing the entire product around that assumption. So yeah, in the basic version, you can do 120 kgs, but can be upgraded, if the demand is there.
Thanks, Silard. And I assume Peace is probably working on a solar mill, and why all these questions are coming through.
Yeah.
Okay, I think we have to let you go now. We're over time. But I wanted to thank Silard for coming along and answering all these questions. It was really great to listen to all of this. And all the recording will be available online. I'll post some post-event resources as well. So look out for all of that on the CrowdSolve page. The recording will be shared through YouTube as usual. So thanks, Silard. You don't have to stick around for the end. I'm just going to go through some short feedback surveys for the students for our own benefit.
All right. Thank you so much for having me. It was a pleasure talking to you guys, and I will be sending the presentation. Have a good rest of the day, everybody.
Looking forward to it. Thanks, Silard. Okay, so as usual, you have the short feedback survey. So if you just follow through the QR code, I'd just like some feedback on how these webinars are going, what you think of them, and how we can improve them. So this will help us improve for the rest of the year and for future years. So as usual, we hope you enjoy them, but we are completely open to any sort of feedback you might have, positive and negative. Valerie, you're asking me a direct message about joining your CrowdSolve group. Sorry, I've been away for the last 2 days on a strategy section, so I haven't been able to address those yet. But I'll be chasing up with the CrowdSolve developers today and see if we can get you on in your CrowdSolve group. I hope that's okay. I'll be in touch over email. Otherwise, we also have our usual newsletter sign up. So please sign up for that. We'll also be sharing the newsletter on the website and on CrowdSolve. So you can look out for it there, but it's always helpful to get signed up, learn about industry news, some news stories, and that can kind of last you after the challenge as well if you want, if you're still interested in the sector. So sign up for that newsletter if you're interested. They only come out quarterly, so you're not going to fill up your inbox. Otherwise, that's the end of the session, and I just wanted to thank you all for coming. We have, I think, a drop-in next week. If you have any questions, I'll be available for that hour, and I'll be in touch about any future webinars. I think we've got one more thematic webinar for the year, and one more career conversation. So we're coming up to the end of our events for the year, so I hope you enjoyed them. But we'll have some other sporadic things throughout the year. But I'll let you all go now. Thank you for coming. Sorry for going over 5 minutes. And I'll see you all soon. Goodbye.
Thank you. Goodbye.
Sorry.